A well-known feature of Jupiter is the Great Red Spot, a persistent anticyclonic storm located 22 degrees south of the equator. It is known to have existed since at least 1831, and possibly since 1665. Images by the Hubble Space Telescope have shown two more red spots adjacent to the Great Red Spot. The storm is visible through Earth-based telescopes with an aperture of 12 centimeters or larger. The oval object rotates counterclockwise, with a period of about 6 days. The maximum altitude of this storm is about 8 kilometers, 5 miles, above the surrounding cloud tops. The spot's composition and the source of its red color remain uncertain, although photo-dissociated ammonia reacting with acetylene is a likely explanation. The Great Red Spot is larger than the Earth. Mathematical models suggest that the storm is stable and will be a permanent feature of the planet. However, it has significantly decreased in size since its discovery. Initial observations in the late 1800s showed it to be approximately 41,000 kilometers, 25,500 miles, across. By the time of the Voyager flybys in 1979, the storm had a length of 23,300 kilometers, 14,500 miles, and a width of approximately 13,000 kilometers, 8,000 miles. Hubble observations in 1995 showed it had decreased in size to 20,950 kilometers, 13,020 miles, and observations in 2009 showed the size to be 17,910 kilometers, 11,130 miles. As of 2015, the storm was measured at approximately 16,500 by 10,940 kilometers, 10,250 by 6,800 miles, and was decreasing in length by about 930 kilometers, 580 miles, per year. In October 2021, a Juno flyby mission measured the depth of the Great Red Spot, putting it at around 300 to 500 kilometers, 190 to 310 miles. Juno missions show that there are several polar cyclone groups at Jupiter's poles. The northern group contains 9 cyclones, with a large one in the center and 8 others around it, while its southern counterpart also consists of a center vortex but is surrounded by 5 large storms and a single smaller one for a total of 7 storms. These polar structures are caused by the turbulence in Jupiter's atmosphere and can be compared with the hexagon at Saturn's north pole. In 2000, an atmospheric feature formed in the southern hemisphere that is similar in appearance to the Great Red Spot, but smaller. This was created when smaller, white oval-shaped storms merged to form a single feature. These 3 smaller white ovals were formed in 1939–1940. The merged feature was named Oval Ba. It has since increased in intensity and changed from white to red, earning it the nickname Little Red Spot. In April 2017, a great cold spot was discovered in Jupiter's thermosphere at its north pole. This feature is 24,000 kilometers, 15,000 miles, across, 12,000 kilometers, 7,500 miles, wide, and 200 degrees Celsius, 360 degrees Fahrenheit, cooler than surrounding material. While this spot changes form and intensity over the short term, it has maintained its general position in the atmosphere for more than 15 years. It may be a giant vortex similar to the Great Red Spot, and appears to be quasi-stable like the vortices in Earth's thermosphere. This feature may be formed by interactions between charged particles generated from Io and the strong magnetic field of Jupiter, resulting in a redistribution of heat flow.